This whole retrieval augmented generation workflow may seem complex, but let's start to build this one by one using a fine-tuned Llama model, Langchain APIs, and your custom PDF documents stored in our vector database. Hey guys, welcome back to my channel. It's an exciting time in the world of artificial intelligence, especially with the incredible strides we have seen in large language model space. ChatGPT recently dropped the GPT store, giving you the keys to the OpenAI API and the ability to craft your own models. That all sounds so amazing, right? But I think there is a problem. Despite their standard knowledge, these models often give us answers that are a bit too generic, and let's be honest, not always as reliable as you would like. Now imagine you have a very specific use case where the answers lies on a private set of documents, maybe like PDFs for your compliance or legal issues. So how would we do that? That's where Retrieval-Augmented Generation comes into play. In today's video, we will be diving deeper into this end-to-end RAG pipeline with OpenAI, Langchain and Vector databases. Before we kick off, don't forget to hit that like and subscribe button. Most of the data that we have on the web is unstructured data. So you have the social media feeds, you have videos from YouTube, you have PDFs, images, or audio. These are all unstructured data. But the problem is that we cannot store this data directly into a relational database. So there is no relational database that stores up video, right? So how should we go about doing or storing this data? So imagine this is the cat, this cute cat here, this one. She's so cute, right? This cute cat. Like, we cannot store directly this cat in the database. It doesn't give us any value. So we need to store some kind of a tags associated with it. In machine learning, this cat will be represented as a form of pixels. So each of these pixels are representing the portion of the cat. But these pixels are not enough to determine what kind of cat is this, right? So we need to store some kind of... So we will need some kind of tags to identify this cat, all our similar cats. So that's where the concept of vectors embeddings comes into place. So this is like a processing step on top of this image. So what happens here is you have your unstructured data. Then you pass it or feed it to a model that generates vector embeddings. So vector embeddings could be of the form like this. You must have seen this in ML, like with vector form. So the whole pipeline looks something like this. So you have the unstructured data, then pass it to the model. The model generates vector embeddings and stores it in a vector database, something like this. And then these are indexed or to perform some kind of a similarity search. So let's say each sentence is broken down in a set of vectors for vector embeddings. And you can see that you can have these vectors represented as a dimension space. So in this case, grandfather, man, adult, these are some of the vectors. So let's say you want to find two nearest sentences. So you can calculate distance by doing nearest neighbor search. Vectors can have multiple directions, in fact hundreds of dimensions, and storage could be huge and accessing will be very, very slow. Not only that, we will need some kind of an indexing data structure to address this huge amount of storage cost. And that's where the concept of vector databases comes into play. So we have multiple vector databases available. We must have heard of Pinecone. There is one from Redis as well. Postgres also has a wrapper for vector embeddings. There is single store as well, Cassandra and others. Now you can use these vector databases in Retrieval-Augmented Generation workflow. This is how an end-to-end RAG process looks like. There is a video from OpenAI that explains this concept very clearly. You can find full link of video in the description, but let's hear from them what exactly Retrieval-Augmented Generation is and how it works.
We've evaluated, we've identified the gaps, and now we're trying to decide whether it's a retrieval-augmented generation that we need or whether it's fine-tuning that we need. And it's sometimes useful to think of it as like a short-term memory versus long-term memory problem. So if we think of it as perhaps like trying to prepare for an exam. So your prompt is giving them the instructions that they need to complete the exam. The fine-tuning is like all the studying that you do beforehand to learn the like methodology and like the actual framework that you need to answer those questions. And retrieval-augmented generation is kind of like like giving them an open book when they actually go to the exam. So if they know the methodology and they know what they need to look for, and then retrieval-augmented generation means that they can just open up the book, go to the right page, and actually pull the content that they need. And that's why these two things like solve very different things. Without the methodology and without the content, it can be impossible to solve certain problems. And in this case, we're assuming that we've got a short-term memory problem. So we want to give the model the right context that it needs to answer the question. So Retrieval-Augmented Generation, or RAG, is all about giving the model access to domain-specific content. So quick recap of like what RAG is. I know, again, most people in the room are going to be familiar, but I'm just going to recap this for the benefit of all. So you'll typically start with like some kind of knowledge base or some kind of like area that you want to get some content to then that you want to use to answer these questions. So in this case, we're going to use like a fairly typical flow, which is we've got some documents, we're going to embed them, we're going to stick them somewhere. Again, I know folks out there probably have their own search services, all their sources of documents that they would use, and that's fair enough. But for this example, we'll assume that we have some documents, we embed them, we make a knowledge base. Then when the user comes in, they're going to ask a question. Let's say, what's the population of Canada? We're going to go, and instead of giving that directly to the LLM, we're going to fire that at our knowledge base using some kind of search. Let's imagine we do like a similarity search. We're going to pull back some content. So we have some content that says what the population of Canada is. And we're then going to combine that with a prompt. So we're going to give it to the LLM and say, here's the question, here's the content, answer this question with this content. And we're going to end up with a, hopefully, correct answer. So quick recap.
Thanks to OpenAI for sharing that video. Honestly, that video is so good. I would recommend everyone to watch that video. Link is in the description. So now we have an understanding of what vector databases are and what RAG architecture looks like. Let's try to build it now. Awesome. So the first thing that we need to do here is to select the right runtime environment. From the drop down at the top, we can choose the runtime environment. Severally, Colab comes with default CPU as the environment, but we can select GPU. It comes with 1 unit. Next thing is to get the right model. So in this case, we'll be using Llama2 as our LLM model. I'm using a 7 billion parameter Llama model. If you have space, you can use a bigger model. You can download this model from Meta's GitHub account. For the vector database, we'll be using ChromeDB, which is a vector database from Langchain. Since we'll be using Langchain API for most of our services, so it's better to use ChromeDB here, but you can use Pinecone, Redis, or Elasticsearch if you need. Rather than keeping it as an API, I would rather use it as an app. So I would be integrating Gradio in this example. You can check out Gradio. It's a cool project. It provides interface to your machine learning models. The dataset I will be using is a PDF dataset, which is available from the Dell website, but you can use whatever dataset you want. Generally, PDF is recommended for this example. So these are some of the example requirements, like you should be able to change the model parameters with slider, memory is intact and conversational using chat history key, create all types of content such as email, product description, and you should be able to directly query given a title of the document. Let's install some of the packages that are required here. So first thing that we need is the Hugging Face app. So let's install Hugging Face first. And then we will need this API to access Hugging Face. So we can download the access key using the settings menu. There are a few other packages that we need to install. One of them is PyTorch, then Transformers. We'll also need Langchain, ChromaDB, and PyPDF. PyPDF is to play with the PDF APIs that allows us to edit and read. Next up is the Xformer library that we need to install. It's a PyTorch library which hosts flexible transform of parts. So we don't need the whole end-to-end transformer model, but we can break it down and select whatever parts that we need. Then there are a few libraries that we need to install for vector embeddings. So this includes sentence transformers, instructor embeddings. So we need to install those as well. The next library that we'll need is Accelerate. Accelerate is mostly to radio PyTorch code across any distributed configuration. And then Bits and Bytes. Bits and Bytes is a lightweight wrapper around CUDA custom functions, in particular for 8-bit optimizations. So all the libraries are now installed. I had some trouble setting up CUDA on my previous GPU instance, so I had to change the GPU instance, but now everything is up and running. You can see the CUDA environment is also set up, and I'm using the number of CUDA devices as 1. Okay, let's try to load these libraries. So I'm going to import all these Seems like we're getting an error here. Cannot import thing. Oh, I think I know this. I've seen this before. It's probably I need a Hugging Face upgrade. So everything works now once I've upgraded it to the latest version. So I need to download the Hugging Face Instruct embeddings model that converts our PDFs into vector embeddings. So it's going to be using instructor large. Path has downloaded the model. Seems like the tokenizer H1 is downloaded. Everything looks good. Step is to decide the chunk size. If you want to provide large text overviews and summaries in your response, then a chunk size of 800 or higher is good. But if you want specific answers based on extracted content, then less than 800 is better. So now you need to create the vector database. So you can use any vector database. For this one, I'm gonna use a Crowbar. I already installed it, so I'm just gonna pass the directory as well as the embeddings, which we downloaded, the instruct embeddings from Hugging Face. If you haven't downloaded the database, then you can use the previous cell where I have specified the code for accessing the database. Now let's prepare the chat model. So I'm gonna download the Llama2 model. As I mentioned earlier, 4-bit. 4-bit, though stores periods in 4-bit, the computation still happens in 16 bits. The problem with 16-bit is that it will require 13 GB of memory, which we don't have in the notebook. So yeah. Further optimizations can be done with double quantization. Next, we need the 4-bit precision model. So I'm gonna call this API from pre-trained. To download this, so it's going to take some time, so let's just wait. So we got the tokenizer from the pre-trained model that we downloaded. Now we need to set up the chat memory and some configuration parameters. For the chat memory, for the LLM is basically a copy of the chat history that is given to the LLM as in reference, so we're going to set that. This is the function where we have most of our business logic. So we have user variable input from the query, prompt template, pipeline setup, chain setup, and response output. So let's look at this one by one. So I'm passing here question, chat history, system prompt, maximum new tokens, temperature, top tier, top P, and interpretation penalty. And then this is the Llama2 prompt. Let's define the Llama2 prompt template. The next step is to set up the Hugging Face pipeline. So I'm going to specify different parameters. So the Hugging Face pipeline needs a text pipeline. So I've passed the text generation. The model has been passed here, which is the Llama2 model. So we have the prompt template from Hugging Face. We'll need the input variables are summaries, chat history, and question. And then we'll pass the Llama2 prompt template I defined earlier. That included the system prompt, summaries, chat history, and question. So the last step here is to make this as a chatbot. So I'm going to use Gradio app here. So first I want to create a chat interface, specify the chatbot, and then I'm going to create a server. So Gradio creates a server by specifying the server name and server port. So the chatbot is now live on port 7861 running on localhost. For collab, it will be a little bit complicated to set up on the server, so I kind of set it up separately. And this is how the interface looks like. Pretty exciting and pretty new UI. So that's all from our side. You can find the notebook link in the description. Let me know in the comments how did you find the video and if there is any topic that you want me to cover. Till then, yeah, please don't forget to like and subscribe and let us know in the comments.